great film. I'll just take 2-3 examples as a company which we did, departing from the additive manufacturing. CMTI had developed a small system for smart manufacturing of the machine tools. Now, machine tools are traditionally using the lathe and the CNC machines. Now, to manage hundreds of CNC machines and lathe machines is a challenge. So CMTI, being an expert, had a whole lot of data available as to how to do predictive maintenance, how to do the efficiency calculation, how to do the quality management. We as an industry took that initiative of working with them, and today we have a full solution which can now go global. Okay. In the same way, AKtU, which is Department of Atomic Energy, had developed our experts in laser, and we use their laser to make the additive machine. And today, the metal machine which we have been able to make with the help of AKtU in terms of technology is half the cost what is available in the world, and at least has better, if I don't say better, at least equal specifications of what is available in the world. So it takes identification, and I think like you said that the seminars help the educational institute in terms of understanding the needs. The same way the educational institutes, the research which they have done, they need to propagate it, and through the various seminars, and invite the industry to look at what has been done by the various professors to know, and for the industry to know what can be done together. So I would say it's a two-way street. The industry is looking for technologies which they would be able to indigenize and will be able to produce and will be able to take it across the world, in the same way as the educational institutes and the faculty is looking for how and what are the emerging technologies which can be taught to create higher level of employment and higher level of research. Now I will start with the additive manufacturing as my topic. Can I have the pointer, please? You'll have to give it to me. Will it have that range? So AKtU as a company is working in various emerging technologies and enabling the people, the industry, the customers to leap forward and not just walk. The major focus is in the various areas of emerging technology, and what could be the emerging technologies I'll share with you. Today as a company, we are close to about 400 people as an MSME unit, and have grown and are, since we adopted the emerging technology, are growing reasonably faster. What are the various emerging technologies? They could be robotic, they could be IIoT, they could be artificial intelligence, they could be 3D printing, blockchain. We work in 4 of the technologies and not all of them. As a company and as a academia, why these emerging technologies suddenly are growing? If you look at it, it's a need of the day. We cannot neglect it. The product requires personalization, and that to mass customization. Customization. The cycle time of the product globally is reducing. The products are becoming smarter. Now, when you say smarter, it means integration of many engineering knowledges, whether it's electronic, whether it's mechanical, whether it is pneumatic, all of them need to be combined together. Now, previously we were running it in one stream by doing one prototype, then integrating electronics, then integrating software, then integrating other things. Today we cannot afford it. And if we cannot afford it, we need to turn around the product cycle in a much, much faster way. And if we have to do the product cycle in a much faster way, all the people are not available at the same location. So today, the global centers of R&D are coming up in India. And if they are coming in India, they are spread across the world. If they have to do, we need to create the prototype, we need to do the product development in a much faster manner. And what can do? One of the technologies, because I can touch on other technologies as well, one of the technologies which is helping it is 3D printing, which is a disruptive way of reducing the time cycle significantly, both for product development as well as for manufacturing. I'll give you a very quick example of a student who came from an incubation center and wanted to design a mixie. Very simple. The motors are purchased, but to make the mixie would mean die making. And die making would have taken him at least about 5 to 6 months. Maybe he would have gone to China to get it done. If he launches with one mixie, which would have costed him in capital cost of nearly 30 to 50 lakh rupees, do you think an incubation center can run it? He will fail, because he would have to practically mortgage his whole money and then be able to launch a product like this. What did he do? He came to us and I talked to him and I said, why don't you launch 5 mixies rather than one mixie? Because one mixie no one will accept it. He said, sir, I can't afford it. Do you know the whole mechanism was finished in 2 weeks' time for 5 mixies at a total cost of 12 lakh rupees. Does it make change? Does it revolutionize? And does it help incubators to be able to take their product forward and be an entrepreneur as much as seeking an employment from other people? It makes it speed. It gives you the flexibility of choosing alternative designs. It helps you in innovating and making cost-effective solutions and bringing in the smartness of the product. It also helps you in reducing the cost of launching the product, practically taking away the capital cost. So why should we not learn? Why should we not introduce in our colleges which will give both the employment as well as give and create employers? Globally, 3D printing is being accepted and is being used by different bodies. Whether it is the government bodies or it is different areas of applications from aerospace to other applications, it is also being used for functional parts. Today, 66% of the functional parts are being made by 3D printing. So impression is, it's only for prototype. It is no longer remaining a prototype solution. You would be surprised to know that during the COVID period, our factory ran 24/7 to make more than 1 lakh parts for ventilators. In the second COVID, the oxygen generators, which were in dire shortage, we were making the sieves, which could be made by 3D printing with a turnaround time of less than 1 day. Okay? That's the power of 3D printing. And it's functional parts. And you can see a whole lot of functional parts which are brought to show it to you, to experience, to share and see what can be done by 3D printing. It's being used, next. Globally, it is expanding at a growth rate of close to 23%. Now, 23% is not small growth rate. Okay? Unfortunately, India has not taken that deep initiative so far, but it is growing. Some of the industries like drone, 70-80% of the parts of the drone industry are today being made by 3D printing. Medical implant, I was just sharing it with Mr. Gita Gupta an example that Many people have the back pain, okay, for various reasons. And what do? We put a belt. Now, if we could create a scan and a structure which could support the back, my back pain will be taken care of. I don't have to move. So it's a brace which I need to make and be able to utilize it for my back pain. Similarly, when a knee joint is being made, which is implant, what do? Today, an implant are available in different sizes. Now, when they are available in different sizes, they don't depend on the shape of your bone, but every bone is different. Now, when every bone is different, what do? The doctor cuts, rubs the bone to fit the implant which comes in. So when you go after the operation or your parents go after the operation, the doctor says, I have done everything right. But your parents are feeling the pain. Why are they feeling the pain? Because the doctor has done the right job. It's only because the bone which has been rubbed or has been cut to suit the implant will need to be recovered. Now, if it needs to be recovered, it would take its own time. On the other hand, if I could make the implant which is exactly as per the shape of your bone, the doctor doesn't have to cut the bone, and therefore his operating time goes down and the pain will not be there afterward. And can it be done by any other means by doing the casting or by doing the forging? No way. It can be done very effectively in 3D printing. And you will be surprised to learn that more than 1 lakh knee joint and hip joints are being made in India today, which are being supplied to Indian doctors as well as global requirements. Looking at the versatility, looking at the speed, looking at the flexibility, look at how many customers are adopting it in medical, aerospace, engineering, civil, mechanical, every stream of science it is being adopted. The growth is not coming just because the mechanical 3D printers are coming in. There is a need of material science, there is a need of software, and if we neglect any one of them, we will never be able to achieve the success. And today, practically global companies in material sciences, global companies in software, in technology are working to make the 3D printing more effective and be able to utilize it. We as a company have many systems available in our plant in Noida, and I would be very happy if any one of you or many of your students come and work or see what is being done and how 3D printing is being utilized on a day-to-day basis. Practically, we produce close to about 500 to 600 parts of different types every day, in different materials, in different technologies. Why? Because no tooling, reduced manufacturing time, no minimum order quantity. So we can make 1 piece, we can make 100 pieces. Customized product which can be lightweight, which is a critical requirement of energy saving and energy efficiency. We can do integration of many parts which gives us a higher reliability. To give you an example, a company came which was making this water purifier. If you open the water purifier, you will see 3 different systems which are connected, and there is a rubber washer which is there, and that's the one which leaks the maximum. Imagine if I could make it as an integrated part and could fit it on those 3 cylinders, my reliability of the product would be so high that I don't have to change the rubber and I don't have the leaking problem of the RO system. I don't know how many of you know the technology. I can skip this or I can continue with this. How many of you are familiar with 3D printing? Oh, a lot of you. So I'll skip many of the parts. It's a section by section printing. It's a additive printing, and therefore any geometry, any complex geometry can be produced. I can share. Can you think of this geometry being manufactured by injection molding? It is not possible. right? It would have been made into 7 or 8 or 9 parts before the part could be produced. This is the battery casing of the new car battery, which is coming up. So, just to show it to you, I don't know how to show it. Oh, sorry. I'll just show one of them. Can it run? Yeah. This is the simplest of the technology called FDM technology, where the plastic material is melted, it is mounted on the X, Y and Z, and with that X, Y and Z, you are producing a layer. So you cut the part into slices, and after the slices are cut, you are able to produce the part with the geometry which is given. And why it is called printing? Because you are almost writing with the pen the geometry as it is required. So that's how the parts are made. Can I skip? Okay. So there are different types of technologies. These could be SLA technology. I won't show everything because of the shortage of time. There is a DED technology, which is what we are making it at our own factory in Indore, where we take the help of Department of Atomic Energy, and we, as an incubator, are now even using the laser which have been developed for different applications and converting it into the metal 3D printers, which are not being made in India. So far they were being imported. So here, what we did innovation is that we actually, normally when metal is printed, the oxidization happens. We completely avoided the oxidization. Instead of filling the whole chamber with the 3D, with the gas, which is argon gas, we pass the argon gas through the nozzle itself. And when we pass the gas through the nozzle itself, there is no question of oxidization, and the gas consumption goes down, and argon gas, which is a heavy gas, which displaces oxygen, it will not spoil the environment so much and will be able to utilize it. I have the slide for that. I have the fusion technology, which is a new technology which is there from Statisys as well as from HP, where what is done is that you don't heat the powder, you actually make the powder and multiple parts can be printed simultaneously. It follows exactly like inkjet printer, but the only thing is the ink which is used is a thermally sensitive ink. And since it's a thermally sensitive ink, as soon as the fusion lamp comes in, the parts get produced. The other key aspect, which many of us, like I was talking to Madhukarji, and Madhukarji was talking about the recharging and the solar cells. I was of the opinion that Madhukarji did touch upon, that why can we not build up AI to increase the efficiency, because most of the solar cells after 1 year are working at close to about 60-70% of their efficiency. Am I right, sir? Or less or more? More.
I think degradation is about 1%.
A year? Cleaning and other things can become important. So if we can put some of the AI tools, we can improve the efficiency both in terms of orientation as well as in terms of cleaning, and then increase the efficiency. Maybe, it's my first thought, we'll need to develop upon that. Software plays a key role in 3D printing as well. To look at the part, if you look at this part, at the first part, which is on the left and upper side, and look at the part which is at the bottom, the weight reduction is nearly 40%. And if you reduce the weight by 40%, you are able to achieve costs which are lower than the traditional manufacturing cost, and parts which are much stronger. A company came with an LED company. Okay? So there was a company which was making an LED, and they were doing the aluminium extrusion. Now, aluminium extrusion, they were fitting the two joints and fitting the LED within that. They had to provide a paper insulation. What we did, it was a 49-gram part. What we did in discussion with the customer, reduced that weight with a lattice structure, and by using the lattice structure, we reduced the weight to 12 grams. His original cost was 650 rupees. That cost came down to 520 rupees. Okay. And then what did he achieve? Reliability, no heating because the paper insulation gone and the air cooling could be done. So you could achieve higher efficiency, product working and reduce cost. We work today in almost all materials, whether they are ceramic, metal of different type, rubber and other things. What do these materials give you as a property? They give you the flexibility, they give you the functionality. So you can achieve almost like what you would like to have as a single part. I'll share with you one part. This is a heat exchanger. Now, in the heat exchanger, the cooling is passing through this and there is a cylindrical duct which has been created. Can you create a cylindrical duct inside the part without a section being created? No way. But because it's edited, you are able to create the tubings and the fins in one go in less than about 7 to 8 hours time. And with that part, you are able to improve the efficiency, reduce the space, and are also able to work with the better heat exchanger in the system. So these are the type of some of the parts which can be produced with the help of this. So today, as an organization, you need to work on software, you need to work on the hardware, you need to work on the materials to be able to give effective solutions for various applications, whether they are tooling, whether they are parts, jigs and fixtures. So today the jigs and fixtures can be produced. You could, can't see it. Okay, there are different equipments which can be made with the help of it. They could be casing, they could be EMI casing, they could be ESD casings, they could be carbon composite materials, they could be fiberglass which can be used for making the hard parts. They could be flexible parts which could be done, or the gear mechanism which can be done. It's being used for MRO application, which is repair application. It's being used for functional parts being done and applications like this. So if I just a couple of pictures which I showed it to you for showing how the ducts can be made. 3D duct is a very critical application in an oil and gas. Now, if I had to make the duct for the air conditioner, what would you do? You'll bend the tin, and with that tin, you will make the vents. Now, and if unfortunately or fortunately in the design, you have a square on one side and the rectangle, circular on the other side, the designer will break his head to make that tin thing, and the flow will never be uniform. Using a 3D printing, it's no business because you can make a 3D pipe like this, and the flow is uniform, right? Can you make it in tin? Can you make it in any molding? No way. And you could fit it, and there could be different dia here and a different dia here, or there could be a different shape here and a different shape here. But it's very easy for 3D printer. So that's what I mean to say. Applications are phenomenal, the technologies are available, and I can go on and on. The time is limited. I think I will not like to bore you with so many applications. I'll run through quickly these showcase on how 3D printing has been utilized by companies in electrical switching, in transparent material, in educational model, in robotic models, in grippers, in drones, in customized car making, huge number of applications you can see. It's been used for tooling, which used to take very long time, and the tooling and jigs and fixtures can directly be made using the 3D printing. Of course, it can be used for mannequins, and you would be surprised. If I show you, this mannequin could be created using 3D printing, and even Ram Mandir could be created using the 3D printing. Sir said that don't touch on Ram Mandir in technology world. I'm showing it not only as Ram Mandir, but how close and how precise work can be done with the help of 3D printing. It's being used for planning the terrain and for town planning. So using the satellite images, using the terrain model, you could directly print it. It was used very effectively by the army during the Galwan fight. This is a machine which we make ourselves. It's an open-end machine as a technology where we can print in ceramic, where we can print in composite, and there is a lot of indigenization and design which we did to make it effective and be able to give to the educational institute a wide range of material, and we work with granules so you can work your own material in this. So sir, I think this is the machine which we made with Department of Atomic Energy, and it is working today. It's being used for repair. So the way to proceed for your colleges and for your universities, you could, instead of, there are small printers which are available at 25, 30, 40, 50,000 rupees. You will be fooling yourself because you are using it as a hobby printer for professional work. Use a machine, use a system which is professional system which can print functional parts, have a combination of reverse engineering and the functional system to be able to make a meaningful functional system for your colleges and universities. Thank you very much. So anyone of you can see, work, and look at these parts, and I would be very happy to invite you.
टर्बाइन थोड़ा और बड़ा बनाओ, फिर फिजिकल टर्बाइन
It's just an educational model someone wanted to look at how the turbine actually works and what are the type of blades and it can rotate at about 800 RPM.
Thank you, sir, for your wise words and a very interesting presentation where we've also gotten to see physical models of what can be produced with 3D printing. I would invite people from the audience if you have any questions for sir or for any of the speakers thus far. Please feel free to ask. Yeah. Mics, please. 1 second, sir.
Manufacturing, which one is the reliable and very easy to create this type of product? And तो TED भी है सर और 7 types of categories हैं. उसमें सर थोड़ा सा डिस्टिंग्विश करूँगा. उसमें डिफरेंशिएट करने में प्रॉब्लम होती है कि कौन सा हम ऑप्ट करें, TED ऑप्ट करें कि एनर्जी डिपोजिशन, डिफ्यूजन और एक सर आपने इंस्टेंट बताया वो. तो उसमें सर सारे प्रोसेस में जो कॉस्टिंग होती है, उसमें ये जानना चाहता कि किस पे हम फर्दर.
Actually, it depends on the type of part.
Yes.
It's not just dependent on the technology. To take an example, if I was producing a very complex part which has also undercuts,
Yes, yes.
a TM system would require a lot of support. And when it requires a lot of support, to remove the support from inside is very difficult. So you would tend to use either a technology which has solvable material, so that you can put it in a washer, in the FDM, and can get the part out. So I think AKtU already has a staticist system which enables you to take out the dissolved parts, the support parts, and be able to print it out. Two, in many situations, you need a particular part with a particular functionality. Let's say very high temperature printing.
Yes, yes.
So the part has to work in very high temperature. Then you would use a technology or the material which is able to do that. Now TPU cannot be printed so easily. Okay? So TPU you can do it in FDM, but then you need to know that in TPU you need to print it at a very slow speed, and when you are printing it at a slow speed, you also have to create the gap between the nozzle and the bed slightly less, because if you create it more, it tends to drag, and when it tends to drag, your quality of the part will suffer. So in each of the technology, you are able to orient and be able to produce the part as long as you are able to do you have a grip on that technology in terms of understanding what bed temperature, how to adjust the material, how to get the right material and be able to do it. It can be done in polyjet. Now, to take an example, I'll show you it. These are two parts.
Yes.
You cannot produce it in the LDM technology. You cannot print it in powder-based technology. Why? Here you need to mix colors and be able to print this. Okay? So what are we doing? We are putting 5 cartridges of 5 different things, CMYK and black, right, to be able to achieve a true mixing of 16.5 million colors and be able to print it. So if you need color, if you need to display, and if you need different show value within the same part, which means the flexibility of the part is different. Here it is softer and here it is harder. So if you are creating hinges in between, then you need this. And this can be done by polyjet technology from Stanford. Okay? You can very easily get that out. So I would say that there is no standard formula which I can say, but I would say that if you discuss a particular part or a particular requirement, definitely companies who have been doing work in this area would be very happy to share that.
Thank you.
I didn't give you the full answer, but that's the best I can do.
सर एसोसिएट होना चाहिए सर कंपनी से आपके
कोई दिक्कत नहीं है हमारे यहाँ जैसे to take an example, I'll just share with you. From Noida Institute of Technology, every year there are more than 100 students who come and spend the day with us. We call it as a technology day. From Alliance University in Bangalore, they come to our place. All the MTech students do visit our place. IIT Delhi Design Center, Dr. Pandey, he brings his whole group of 26 people, which are MTech students, and spend the day with us. We have no problem. We will be more than happy if a group of people come or an individual person come and would like to work. We have 7 researchers working inside the company, okay, who are working on biotech applications, who are working on material science and things like that. We collaborate with IIT Delhi to make a composite system, and with IIT Textile, because they had the 3D weave technology, which was their technology, Dr. Bahira, and we had the composite technology. So we designed a machine for him so that he can print 3D V using the 3D printer and be able to make the aerospace parts. So when I made the presentation to ISRO, the biggest problem today globally is that they laminate the composites to make a bigger part. In the 3D we don't. So we cross-mingle the technology of 3D, which is applicable in textile, with the composite technology to be able to make the part which will now go in governor. Okay? So I have no problem in collaborating, sharing, discussing these technologies.
Thank you.
I wanted to say something. No, sorry, that? Okay. Any other questions? Okay. So, in the interest of time, we will proceed. And just before we close this inaugural session, I would like to invite Vice Chancellor Devi Pandey to the stage. We would like to felicitate him with a certificate from ASME, and I will require Madhukar Sharma to present that certificate. Can I have Sir, I would like to stay on stage. There is a certificate for Dr. Rajiv Kumar, which Madhukar, please collect from BC sir, which we will pass on to him once we are back in there. I would require DC sir to also give the certificate to Mr. Deepak Gupta on our behalf. Deepak sir, can we have you on stage, please? Stage. Can I have a round of applause from all of you, please? Sir Uchanji, can we have you also on stage to receive the certificate? Thank you. I hope you all enjoyed this inaugural session. We'd like to take a few minutes to clear the stage, and while we do that, we would also like to invite the panelists for our next session. The panel is going to be led by Dipankar, so I would require Dipankar Bhattacharya on the stage. Can I request the volunteers to please clear out the stage, so what are the mementos? I would request Dipankar to now invite on stage all the panelists who are going to be part of this session.
So we are in the cusp of morning and afternoon. I think my watch shows exactly 12 o'clock. So first of all, good afternoon to everyone. It's my privilege and honor to be moderating this session with a very august set of panelists. So let me invite one by one all of them to stage. First of all, may I invite Mr. Sanjay Prakash from Jindal Water Give him a warm round, good round of applause. Next, let me invite Mr. Sarup Chand. From Android Tech. Then my good old friend Mr. Ramesha from LTED, leading the education initiatives. And obviously last but not the least, Mr. Puneet Sharma from the New York Group. Just give me a second. Just try to. Okay, before I start the panel, first of all, I would like to thank the host institute, AKtU, led by the Honorable Vice Chancellor, Professor J.P. Pandeyji, and Mr. Madhukar Sharma and the entire ASME team for giving us an opportunity to have this panel discussion on a subject which is very, very close to my heart. So I am Dipankar Bhattacharya, and currently I am leading the education initiatives for the mentioned group. The way we will structure this panel, if it is okay with all the panelists, is I'll just give a brief introduction of the topic. The topic is reinventing the real potential of India's manufacturing and infrastructure segment, the opportunities in this core engineering sectors, and the second part is what are the emerging job roles in this specific core sectors. So we have a very august panel from various sectors. We have people from the technology sector, we have people from the infrastructure sector, we have people from the oil and gas sector, and pipeline sector. So let me just start this, very, apt topic. I think many of my esteemed colleagues in the inaugural session, including the AICT member secretary, spoke about the relevance of core disciplines of engineering, like mechanical, civil, and other allied disciplines. And how do we raise the branding and perception of the core disciplines of engineering? That is point number one. And why the demand or the enrollments for these core disciplines are continuously going down, in spite of the need and requirements in both these industry sectors, both the manufacturing and the infrastructure segment. So I'll just start off with a very basic, basic statistics of, who can tell me what is the current world population today? No prizes for guessing. Any idea? Okay, the current world population is close to 10 billion. Close to 10 billion, may not be exactly 10 billion. And what is the projected population, say, by 2050? It is expected the projected population is going to be about 50 billion by 2050. And the other interesting fact is a huge percentage of this population is going to be the middle class population. So why I am mentioning this is, with the exponential increase of the population, it has a lot of implications. There are needs for more houses, there are needs for mobile phones, the needs for more highways, so on and so forth. And all of you will appreciate that for all these infrastructural requirements, be it in the manufacturing sector, be it to design smarter products or to build highways. I think the need for mechanical, need for architecture engineering, need for civil engineering is only going to increase. So the question before us is, if the demand is there, why enrollments are going down is the question before us, which I am sure my August panelist is going to throw light upon. And the other thing is, the question before us is, if the demand is there in the industry, I think there is a missing element of the right skill sets may not be there with the engineering graduate. With due respect to all the academia presence here, I think there is definitely a gap between what the industry is looking at, what Professor Rajiv Kumar very, very aptly mentioned, the new age technologies, whether the new age technologies are embedded in our academic curriculum, is the question that are before us. Just to give you an example, I'm a mechanical engineer, and right now working in the AEC domain. If you look at the traditional mechanical engineering curriculum, and I just jotted down as I was sitting down, our traditional mechanical engineering curriculum talks about fluid dynamics, materials, mechanics, manufacturing, CAD design, drafting, so on and so forth. But if you really look at the industry from a mechanical design and manufacturing perspective, I think one of the key requirements is things like generative design, things like computer engineering, systems engineering, embedded electronics, design for manufacturing, design for additive, and so on. Mr. Sarup Chalbari very aptly spoke about the need for additive manufacturing. Similarly, if you look at the AEC segment, you have different phases within the AEC life cycle. So you have the planning and design, you have the build plus construct, and then you have the operate plus manage. So if you look at this entire AECO life cycle, then you have, you need to embed new technologies into the curriculum, things like building information modeling, quality assurance and quality control within the BIM life cycle, and various other technologies which is the need of the hour even in the AEC market. So just to sum up, I think the new job roles in each of the sectors are going to be very different in the present, and it is going to evolve even in the future. So I think the need of the hour is to look at what are those right skill sets and have a very strong industry academia collaboration to really meet the fulfilling demands and the aspiring demands of the industry, and so that we raise the branding, perception, and the needs of the industry for the conventional disciplines of engineering, for the new roles that are available in the industry. So with these few words, I think the way we will structure the panel is I will let my August panelists to give introductory remarks, maybe for a couple of minutes on this very pertinent topic. And then I will have one or two pointed questions to each of the panelists. So maybe we'll cover about 45 minutes on this, and the last 15 minutes we will open the floor for the Q&A session. And then maybe we'll have a concluding remark for each of the panelists. So we'll try to, we have about an hour, am I correct, Madhukar? Okay. So within an hour, it's 12:10, so we expect to finish by Sorry? 10 minutes, okay. Okay, with that, maybe, do we have mics? Yeah. So maybe, Okay, technology glitch. Not really. So let me start off from my right. Let me start off with Mr. Sanjay Prakash on, in about a couple of minutes, your initial introductory remarks on this very pertinent topic.
Good afternoon, ladies and gentlemen. I am Sanjay Prakash. By profession, I am a mechanical engineer, but I call myself as a miscellaneous engineer. Put the mic closer. I am a mechanical engineer by profession, but as such, I am a miscellaneous engineer because I have been involved in various activities. In the beginning of my career, I was involved in manufacturing heavy water plant, that was fabrication. Then I switched over to cross-country pipelines for gas pipeline, HPJ pipeline. Now it's almost 36 years old, working perfectly. After that, I switched over to third-party certification, that was that Nostre Veritas. You might have heard the name. I worked there for almost 12 years. I was the first person to bring occupational health and safety management system in the country. Then I left AMB and joined back to the industry in Pulgai as a head quality and safety for EPC project execution. Fortunately, I did also the product certification, that is CE marking for medical devices. I had been to many industries, that what were the limitations and some good points also. Then after that journey started here and there, I joined IFS, worked for 2 years. It was building and highway. After leaving IFS in 2 years, I joined Alstom Transmission and Distribution as country head. Then again, after 2 years, I had to leave the company and I joined 6 months in my home, joined Petrofac at Sharjah in engineering and procurement project, $2 billion. Then I returned back, joined Welspun for highways. Presently, I am in a water management company. So, exposure-wise, yes, I have good exposure. I am a trained faculty for ASME to conduct 5-day courses for pipelines. There are 2 faculties available in the country. I am one of them. I am also approved by Alstom for their training institute. This is my brief introduction. I am a registered lead assessor for quality, environment and occupational health and safety. Visited more than 800 companies for auditing. This is my brief introduction.
If you can also briefly introduce this topic. The introductory, what I also meant is maybe, also a little bit about the topic of today's panel discussion.
Okay. See, what I have observed, because I have headed many companies, there is a big gap between institutes and the industry. A live example I can share with you is I was working in that Nostre Veritas. They were doing contract research. That concept is as of now not available. That means industry does require researchers, but none of our colleges are doing those type of things, or none of the institutes are doing this. This is one good area where institutes should collaborate with the industry and start this profession. That is something good. Second area is most of the institutions have not made themselves attractive. Like for any of those high-fi testing, not high-fi, simple testing, also like mix design, complete mix design is a civil job. Most of civil engineers will be able to do in engineering college. But what happens is NHAI will ask, no, IIT or IISc. Mechanical test also, typically a specific example I can give you, CTOD, crack tip opening test, which is very important for your stabilizing rod, which is installed in all the cars. How many chucks it will break? Normally this testing is for 5 lakh cycles. Institutes can do this, but all the tests in the country will go to IIT Delhi only. This is what point I am saying is based on the industry need, colleges should also change their exposure. It is helping in 2-3 ways. First is our students will learn. Second is practically they will see. Third is by virtue of this, our institutions also start earning money. Today we are deprived. We can do all type of testing in engineering college. And if we have earnings, that money can be spent for purchasing those good equipment, which is as of at present it is overlooked. Another area, combination of all electrical, mechanical, civil. See, I have, as I told that I had done good amount of work on occupational health and safety management system. The moment I am speaking about safety, most of you will be thinking, oh, it must be very old hat and helmet. Actually, that is not the fact. Safety has many meanings. Number one is noise. In the good room, like this conference room, I have measured the noise level is less than 50 dB. All our equipments are manufactured below 120 dB, 90 dBA. Means this safety has to be inculcated from the college. This room is well chilled, it is good, feeling cozy, but actually it is not cozy. I am not trying to say the room is bad. There is no fresh air intake in this room. We are sitting in a lecture theatre or classroom or home. Our oxygen level percentage is 20.9% reduces. In my own office, we measured in the conference room it was 18%. With deficient oxygen level, obviously there are associated diseases. First problem is problem in thinking. We have to see that yes, how my colleges start looking in those terms. I can give you n number of examples. I went to this Hero Honda. Their plant was imported from Japan. The height was slightly less. We had increased the height of the working bench by 6 inches. 40 motorcycle production was increased. Now this is just an ergonomics. We have changed the gear and this is how production is. There are many other similar examples. I have not time to use this as a forum. But yes, our colleges, technical institutes, professors have to actively participate and interact with the industry so that we get the newer ideas. And in sum it up, we talk in terms of 4 T's. This T is, we all have problems. Industry also, college also, student also, we are talking nowadays about skill set. From the industry point of view, we do not want any skill from the person. We say, I will tell you in 5 days you have to do this. It is required to repeat. But with the brain. This is primarily expectation. We define our problem with 4 T's. First is terminate. How we terminate our problem. That means first phase is how or what forums we are identifying our problems. I don't need a construction engineer to know enthalpy and entropy. If he is remembering is fine, but it is not required. Second T is treat. Management function is treatment. If you can't terminate a problem, treat it. If you can't treat it, third T is we all are doing that, tolerating. We keep tolerating. If we are not able to tolerate, we say transfer. That means if I am mechanical engineer or civil engineer, let me not do this, I will go in IT. In reality, just see AI modeling and all is all rare people. Maximum people are doing data cleaning. Data cleaning means, say insurance agency say data aya 50 lakh data. These persons are doing data cleaning and sitting in the air conditioned environment, having less oxygen percentage. Their active healthy life is less. So what we are trying to say is our core subjects, mechanical, electrical and civil, is having far more perspectives than what as of now we are thinking, because everybody is running behind IT. But that is also not fact. Recruitment is reducing now.
Okay, thank you, sir. May I also request the panelists to be little brief and short because so may I request Puneet to give his insight on this topic?
Thank you. I'm Puneet. I am the HR for the UOP department within Honeywell. It's the oil and gas licensing team within Honeywell. And to touch upon the topic, and I think my esteemed panelist has already highlighted, a lot of our folks have started realizing that, hey, AI or computer science is the future. What do I do if I land up in a course stream such as mechanical engineering or electrical engineering, or let's say even chemical engineering? Let's take a video. Firstly, let me tell you that I come from an organization where we are looking after chemical engineers and we are looking after chemical engineers like training. We are developing technologies. We need people who are good, sound in their understanding of the chemical engineering concepts for them to understand what technology are we working on. We're talking about the AI, we're talking about the digital arm of it. That's coming in as an augmentation. You cannot deploy those tools if you don't have understanding of the core concepts. I'll give you an example. We have something called the Global Solutions Command Center. Ideally, this command center is working towards taking the data and giving out actionable insights to the refineries. You cannot work on those data points if you don't have understanding of the core chemical engineering concept. Idea or case in point being, we need people with strong core concepts. Those are the people who are going to then use the tools and deliver solutions which the world is expecting to these groundbreaking technologies, right? So definitely there's a huge demand, right? And the thought process that, hey, at the end of the day, all the buck stops at computer science courses or the AI-related industries. That's something that has to go. We have to start thinking in an opinion or in a way, how do I use these technologies? How do I augment my current work using these technologies to deliver excellent outputs? Thank you.
Thanks, Puneet. Sarupta?
Good afternoon. I'd like to give an example. Look at telephone, mobile telephone. 25 years back, it was launched, and around the new technology of mobility in communication, how many jobs have been created? Today, it is mechanical, it is electronic, it is software, it is a repair shop, it is a selling organization, they are dealers. At least about 20 to 30 lakh people, or maybe more, are employed around the mobile technology. Yes or no? If a new technology has a great advantage for the youth, and the topic is empowering, it has a great advantage. No experience exists, and the Gen Y, which is the youth, has an advantage. Why it has an advantage? It is receptive, it is able to learn. Fortunately, we are in an era where there are 7 different new emerging technologies which are coming up. Good old time, automotive came and stayed for 30 years, 40 years and employed so many people. Right? Mobile came, it employed so many millions of people. Today we are lucky that we have 7 emerging technologies which are coming up. Think of the potential and the business employment which you can get. And since no experience exists among people of my age, right, you, me, not you, your students have the great advantage today. And the only thing which you need to look at, how do I make my students adapt my emerging technologies so that we can get employed and be an employer ourselves. In a company, small company like ours, today we have close to about 35% vacancies which we are not able to fill year after year because we don't have the people. And If our company cannot have 35% of the people which we want to employ and do not have the people, think of companies which are very huge companies and who want to do and compete with the global customers to be able to create employment within our own country. I would say empower with technology, empower with emerging technologies, and then I don't think it's not the question of mechanical engineers, electrical engineers, person like him has switched over so many engineering, right? It is a question of engineering, to me, apart from the core subject, is also understanding how to solve new problems. How to identify problems, how to innovatively solve problems. That is what engineering teaches us day in and day out. I'm not an engineer, I'm a physics graduate. Okay? But in my mind, if we adapt new emerging technologies and orient ourselves toward that, we can empower our students both from employment point of view as well as empowering them to create, to be an entrepreneur and be an employer ourselves. Thank you.
Thanks, sir. I'll come back to you. I think you touched upon two very key topics of the Gen Z and the emerging technologies. So I'll come back to you after the introductory remarks. So over to you, Ramesha.
Thank you, Sundarji. First, thankful to ASME for giving this opportunity. Myself, Ramesha, heading the academic initiatives for that time. To take a call on this particular topic, let me begin with the money trail, the need aspect, right? The disruption is happening throughout the world. That's called technological disruption. And that you can see in the product itself. One such disruption is electrification, where we are moving away from fossil fuel to a kind of renewable energy systems, right? Take an example as the EV, right? So, if you have seen the product earlier, okay, the Bajaj Chetak vehicle, whatever we used to drive earlier, 20 years back, it's all about mechanical unique selling points. Okay, it has so much of CC capacity, it can run this particular RPM, this much of comfort. This was the unique selling point that you see in the brochure. But the same product now is electric Bajaj. They talk about over-the-air updates, and they talk about you can charge the mobile, it is connected. So these are all become the selling points. So what is the message it gives is very, very simple. There is a need to identify our learning and the skills. Okay? The industry, what they look at the resume is whether the student is learning latest technology. Can he add value to my system? And that's what we look at. I think this is the most critical point. And second important point is, we just talked about the semiconductor technology. The disruption is happening over here. The Elon Musk want to set up industry over here. So is the money flow, the FDI flow happening in this segment speaks many things in terms of demand, the need and the demand. So Altair themselves have recruited more than 300 engineers in the past 1 year. That speaks there's a huge demand for the skill set, the right skill set. And there's a need for the industry to collaborate with the academy so that we can harness the skillful resources to match the demand. So with this closing remark,
Yeah, thanks, Ramesha. Some very pertinent points. So, thanks, my co-panelist, on those introductory remarks. So, I have a few questions for each of the panelists. Depending on the time available, we'll see how many questions we can go through. Let me come to Mr. Sarupchand first. So you made a very good presentation on additive manufacturing as a technology and what can be done with the technology. So my question to you is, as a company, how are you percolating this technology of additive manufacturing within the education ecosystem of the country?
in my mind, it cannot be done in one way. It has to be, if the university and the colleges do see this as a technology which they would like to incorporate or they would like to invite, I would say that arrange sessions like this for the faculty and for the students. I have addressed students of nearly 500 students together and shared with them for 3 hours, 4 hours as to how they can see a job prospect in different areas. Not in engineering, as an education, this thing. Once the Hindi faculty of Kirorimal College called, you would be surprised how Hindi faculty of Kirorimal College will benefit from 3D printing. When they saw that the same additive manufacturing can be used for making the chocolate, custom chocolate, the same 3D printing could be used for making custom foods. The pharmacy department could see that custom patient-specific medicine dosage could be provided. The fashion design could be created using 3D printing, not only as an equipment but printing on the textile and the garment. They saw that, oh, we can also become an entrepreneur around it. And 2 of the people became actually an entrepreneur who set up a small center of their own to do custom built cakes. And they made the molds, which are very fun and very nice molds, and were able to do it. So empowering the students and empowering the colleges, if I call the people or faculty, possibly they have so much work they cannot come. But when the Vice Chancellor took the initiative, the faculty could come, the students could come and could talk about it. I would say that fortunately I'm also the Indian representative on the additive manufacturing board of the world. So the Indian government has nominated me as an additive manufacturing standards nominee for the World Council of ISO. I would say that the best would be you have the authority of bringing the people whom you think would benefit from this technology. There are enough people who are willing to talk about it, percolate the technology. Alone, we cannot do it. Otherwise, it appears to be a sponsored, paid program where not many people see the benefit of the technology. I would say that the only way we can do is by a joint collaboration. We work closely with Alliance University, we work closely with a couple of universities where we have even developed a full 40-hour program on reverse engineering and 40-hour program on additive manufacturing, and that we give it back to the college and the professors so that they can conduct the course in the college at their home, and we train the faculty.
Yeah, thanks, sir. So, my intention of asking this question because the Honorable Vice Chancellor is here, and AKtU, if I remember, has I think more than 400 plus engineering colleges affiliated. So if such a technology can be embedded in the curriculum as Sir just mentioned, in the form of within the curriculum or as a value-added program, it will be of immense value, and that really connects, joins the dot, because somewhere I think Sir mentioned that he still has shortage of talent. Okay, so I think it will really connect well. So let me move forward to Ramesha now. Technology. I wanted you to touch upon technology and as an enabler for the skill sets of the student, and also how it changes the skill set of the students and changes the mindset of the student.
As you know, it's all about the demand supply. industry demand skilled resources, and that's where we need to have students with the different skill sets. Okay. So being in Altair, it's a company working on computation science, where you think of any particular product that you see in daily life, you can see the usage of the simulation technology over there. But coming back to what industry expect is, let's say academy we have syllabus, and of course we seek knowledge from the professor for the sake of examinations. Okay, it's become a kind of different process. But what if the students want to seek the knowledge because he has a drive in himself, and I'm pointing towards the challenges, and that's why a lot of companies are conducting hackathon events and design challenges so that the students will seek the technology by himself rather than it's part of active learning process that happens in the academy. And this brings extremely talented resources on the table where industry can help. Okay? And Altair is a platform where any student should be able to get the technology free of cost, and the courses are free of cost, which helps my customer in turn to get the knowledge. I mean, get the skill resources.
Just one addition to whatever, just a follow-up thought is, what is your opinion on when you implement technology in the college, be it additive manufacturing, be it CA solutions or any other technology? Is there a resistance to change within the academic fraternity, and how do you overcome that obstacle? Because at least I have found that there is a resistance to use new technology. So any thoughts on that?
Okay. If you force an academic institution to make our tools and technology mandatory, it really does not help the industry. Again, I will tell you a key point over here. Why? Because I want the student to come to our technology and use it. And that's where the skill resources comes into picture. Again, come back to the competition. That means we actively engage ourselves into various competition where we can identify the skill resources who are extremely talented. And any professor who wants to use our technology for, let's say, publications or other stuff, they can associate with Altair and they can get the necessary software tools and technology free of cost. And there should be an ecosystem through which they should be able to learn. Okay? So we have an ecosystem through which the learning process happens seamlessly, so that they can acquaint these particular technology.
Okay, thanks Ramesha. So let me move over to Mr. Puneet. You're an HR leader. So you also mentioned about role of AI. So what in your opinion, in your specific industry, what role AI can play, and how will it will help both the industry and the academy?
Okay, thank you. So I think, as I said earlier, before we jump onto AI, right, so there are organizations that are dedicated to developing that technology. Knowing the core of what value we are going to deliver to the customer, knowing what the customer requires, that is critical. For example, there are tools, there are various softwares to deliver an output to or deliver a certain solution. If you don't know, after you have put in your numbers that, hey, at the end of the day, what solution is this tool generating? What solution is this AI generating? And you don't know the basics behind it, that's going to be a disaster, because when the customers or when your leaders will end up asking you questions that, hey, how did we arrive at this? Not knowing your details, that's going to be a kill. How is it going to be an enabler? As I said, it is going to be an augmentation above your available skill set. AI is great at doing repetitive tasks. AI is great at doing data analysis work, right? So when you are looking at all those repetitive tasks, for example, looking at data repeatedly to arrive at certain conclusion, and that becomes a regular process for you, you can simply put in an AI model to do that for you. The actionable insights that come out, that is where your creativity, your knowledge, your core skills come out, right? So that makes it very critical. So your repetitive tasks go, and you have far more better stats available to you, but how do you use it? It's still dependent on your core skills.
Yeah, interesting insights, thanks. Let me move over to Mr. Sanjay Prakash. You have the pipeline industry. So what are some of your challenges and how you are mitigating the challenges? That is the first part of the question. And what the second part is, what role you perceive the academia to play in working together with you in mitigating some of these challenges?
See, there are various challenges for an engineer the moment he comes in a construction project, maybe a pipeline, highway, or other construction industry. Number one is contract. Contract means a person should always be a habit of reading himself. Summaries don't work. He should be able to read what is written behind the lines also. He should be a good advocate. Advocate means he should understand legal requirements as a minimum, Factories Act, Building and Other Construction Workers Act, Environmental Protection Act, Air and Water Pollution. These are freely downloadable from the internet. Then comes inventory management, procurement. See, everybody can procure and not all can procure. Normally, steel in the pipelines, steel pipe is there. Project cost is based on the cost of pipe. This costing is normally missing with the engineer. They are not doing any costing. If a work is required to be subcontracted, costing is difficult. Like AI modeling, I don't know how the end unit will be costed, but it is a complex situation in terms of software. In our type of industry, you know how many equipments are there, how many people are there, what is the consumable items, and others. In highway, probably people may think some different cost. The cost economics there lies in the diesel, HSD, because if my raw material, that is earth, is away, cost is more. If it is near, cost is less. Earth, the moment I talk about earth, it is civil engineer because they have to identify suitable soil. It means they have to be thorough in their subject as well as few applicable codes and standards. Engineering colleges will normally have those MOD standards and state government price. So costing and requirements helps there. Then procurement. In pipeline, procurement is for line pipe. Pipe mill once it starts manufacturing, they normally don't change over. So the key challenge is, if I am procuring say 100 kilometer line pipe, where to store and how to store. And again, diesel is very expensive, so transportation is also required to be minimum. This becomes a task for logistics and planning. On planning, one side is doing material management, manpower management, equipment management, and primarily money management. All things are required. So those type of things are normally expected from an emerging engineer who is expected in the industry. Then, okay, that my core area one is quality, that means testing. Most of the engineering colleges are having almost all mechanical engineering testing. That means tensile testing machine. In fact, you will not have. A good amount of metallurgy is being taught, machining of preparation of specimen. Our engineers normally are either not interested or not exposed. Last but not least, engineers nowadays are physically weak. I am more or less about 60 years of age. Today, if I talk to 23 years old engineer and say, okay, we site chalte hain for 4 hours, if he is also in sunlight and I am also in sunlight, he will become sick. So the point I am trying to say is, our engineering college playground should also become active because engineers also need to be physically fit. Otherwise, nobody is here in this. Action.
Yeah, thanks, Mr. Sanjay. I think we can quickly go through one more round of questions before I request my panelists to be short and crisp in their answer due to the paucity of time. So let me go back to Sarudha. You mentioned about 7 emerging technologies. Can you give little more insight?
Dipankar, before I get into the 7 technologies, I just want to put one more question in between. Is there a resistance in the institute? Right? I don't think there is a resistance to the new technology. Practically, till now, till last year when NLP program came in, most of the faculty were bound to cover up the course of 40 hours in that time. So there was very little time left both to the faculty as well as to the student to deviate from. Fortunately, this new employment program which has been created, or the policy which was driven, that has enabled the university and the colleges to be able to regroup themselves and be able to create new courses which are needed by the university. And therefore, it is an opportune time when this initiative can be taken in collaboration with few industries, not one industry, and then be able to create courses which would enable the students to take it. The second question which you talked about was which are the new emerging technologies. I did touch upon in the presentation itself that whether it is AI. Now AI need not be only for financial. AI can be for manufacturing as well. As I shared with you the example of CMTI and the collaboration, or the solar wind energy, or the hydro energy, everywhere the AI can become very useful. It could be the big data analytics, it could be the 3D printing. There are multiple technologies which are emerging, and IIoT and IIoT combined with AI. So we can go into the depth of each one of them, and each one of them how they are spreading across the world. So I would say that this is a long topic of discussion, but there are emerging technologies which are helping the youth to be able to get employed. It happened, and you are seeing it for yourself. The app development itself has led to many billion-dollar companies getting formed within India with a small initiative and then taking the venture capital funds and other things. Similarly, the venture capitalists are keen in putting the money in the new emerging areas which they see as a growth areas. So from employment point of view, from empowering point of view, the courses can be integrated, and with that integration of the courses, the empowerment of the students can be done, the employment can be created.
Yeah, thanks, Sarudha. I think some of the technologies that you mentioned, I think, some of them are already embedded in the curriculum, but I think a lot still needs to be done, because I think at the end of the day, the career of a student finally links to either employment or entrepreneurship, or the third, which is not very prevalent, would be the research that you would like to further pursue. So let me move over to Ramesha. I just wanted you to highlight to this audience here about a successful case study for industry-academia collaboration that I see a lot of your LinkedIn posts of MOUs signed. So if you can highlight to this audience here of a case study or some kind of industry-academia collaboration.
Okay. AKtU became a public limited company in the year 2019, and we acquired a lot of technological disruptive companies, and because of which we need to have a strong association with the academy. And because of these reasons, from 2019 onwards, we are looking engaging with lot of academic institutions in terms of signing the MOUs, setting the COEs, and helping the academy so that it in turn help my industry, because my industry is evolving or changing very, very rapidly. So today there will be some technology which they want to adapt to their product. At the same time, they want to make it to the market with a less lead time. Okay, so there's a responsibility on our end to take up this only with the academy because they help a lot. Even for example, you take data science as one example, right? You might have seen a lot of competitions conducted by all. In fact, decision making through data is nothing but data science. Okay, and it is highly applicable to mechanical engineers, electronics, electrical, and civil. They can apply anywhere. Okay, that's most important. Because data, whatever you have, it has. If you get into the particular field, right, math modeling comes into the picture. Okay, but eventually you will find a lot of challenges at this segment. Whether you are really capturing the data or not, that's the first question. Because for data science, the input is data. Once you have data, how many sources of data you have, how to handle this large data, how to store this particular data, and how to mine this particular data. Okay, so we learn a lot by engaging with the academy because they work on different areas which are challenging. Okay, and by engaging with that, we sharpen the software technology useful to the customer requirements. So there's a positive benefit out of engaging with the academy, and that's why we closely work with the academy to have a stronger collaboration in terms of challenges, COEs, and many other initiatives.
Okay, thanks. Let me quickly move over to Puneet. You are an HR leader, so I want to ask you about talent acquisition. So what are the challenges in your specific, what are the challenges that you face in talent acquisition? What are the specific skill sets that you look at when you hire talent in your industry?
Right. I think Mr. Deepak called it out, Mr. Swaroop called it out. I think we definitely do see that gap, right? Whether do I go to a certain college or let's say a certain talent pool, do I get ready talent? Absolutely not. I think Honorable Vice Chancellor also highlighted that in the third year of students we go and pick up and then we start investing in them, we start training them, right? I think the moment there is a collaboration between universities and industry and when people start understanding what the demand of the industry is, what is exactly the demand of the skill that we are looking for, I think these gaps can be bridged. So again, we've had certain challenges in hiring the right set of people. For example, I highlighted the example of GSCC. I need chemical engineers who are keen to work in data science field. So they need to know their concepts, but they also need to know data science. Do I get a ready fit? No. Right? But I need students who have that kind of mindset, who are adaptable, who want to go in that direction and are willing to learn. I think another big thing which is very important for us is, let's say, people focusing only on their specific domain, only on their specific branch. Do we have the spirit of cross collaboration? Do they understand the project is just not mechanical, it's not electronics, or it's not computer science? It's a mix, right? Getting those students, getting that mindset is very important. So, in addition to the skills, the mindset, the adaptability, that's very critical for us.
Thanks. My last question before I open it out to the audience.
You mentioned in your introductory remark about design validation being done only by IITs and IIS. So what's the reason that the next other institutes cannot do it, and your perspective on it?
See, this is very important point. Why only IIT and IIS is in demand for design? Design validation is typically asked in most of our projects. Simple thing is, we have not made our shops attractive. We have to make shops attractive. Try to meet the government authorities in like why my engineering college is not authorized for reviewing and approving design. The moment this thing starts, good amount of revenue also starts, and by default students will also have the better exposure of the industry. Because ultimately in IIT also, professor is not designing everything. Ultimately it is the students. So, and specifically when we have design role is far more bigger. I can give you an example. I was in Saranpur. There was a bridge, three-span bridge of bricks of British period. IIT Roorkee was involved. Now we were not in a position to break the bridge, to make a new bridge. There was no alternative. Somebody from IIT Roorkee had explained that how to make a bridge over the same bridge without interrupting the traffic also. That was difficult, but yes, we could do it. Another example is Sarai Kalika. This was by IIT Delhi. They could provide the solution. That means some research scholars have proposed it. Recently, versus in Mumbai, the 2,000 metric ton arc bridge has been shifted in the water for 62 kilometers and installed in 1.5 hours. This must be IIT Mumbai. This is the technology of civil engineers and obviously hydraulic engineers and obviously high-tech values and all those things. So this is the combination. And I think it will work. Engineering colleges have to start participating with government authorities. Approvals are easy and you will definitely obtain, but you have to write the letter. Thank you.
Okay, thanks. So we have a few minutes for the audience. So I'll take 3 questions from the audience. Please introduce yourself and be very crisp in your question. So any questions from the audience? Please raise your hand. Somebody with the mic will come.
I am Professor Mohan Pandey, Director at AKtU College, Gonda. I have a very pinpointed question regarding the point of discussion that the panel is taking up now. At many of the state government-run institutions, the government colleges or the private colleges, there is a huge rush in admissions to the programs relating to computer science and engineering and IT. We have redesigned our courses, we have introduced industry background, industry-oriented courses in the curriculum for all the disciplines, not only for computer and IT. Where is the gap that from the same institution, more and more number of graduates are getting employed from computer and IT sector, and those who have chosen the core sector like mechanical engineering or civil engineering, they are lagging behind. Because somewhere I think it is a demand-driven scenario also, because if the graduates are getting employment, why will they not choose?
Sure, sir, we got your question, so it seems to positive.
So there must be something which must be looked into very, very seriously.
So maybe any of the panelists
I
can
would
take a
like
shot
to
at
comment
it.
here because I closely work with academic institutions. Okay, it's all about the student aspiration and the family aspiration that the son has to work in a global technology company and work with the IT money. And they don't want his son or daughter to work in a shop floor and second, they wanted to take their son to the different countries so that they can learn post-graduation in those countries to add their skill set. But in reality, the things are changing. It has happened for 3-4 years. Now, the demand for IT has reduced a lot. It's very, very important. And core remains very core. It's very, very important. Only the bottleneck is how we can identify these things relevant to my industry requirement is what matters. Believe me, it really works and it is in need of the hour. I think that's what I want to comment. Thanks.
So I just want to add, I think the visibility, the industrial visibility. So if students don't know, hey, I've completed this course, what kind of job am I going to get? If it isn't there, I think that's where the lack of vision or the tunnel vision comes in, right? I think industry interactions, that is very critical, bringing in subject matter experts, making them talk that, hey, this is your career path forward, I think that would help.
I have just one comment to what he said. There's a famous saying that cow does not give milk, but we need to milk it.
What I wanted to point out was that we are doing everything and anything for all the programs that we are running at the institution. Right? All our courses are equally good. But why is it so? Where is it? The core sector is growing fast also, that is also true. Where is the gap that the students are not opting the disciplines of core sources? Somewhere they are employable also, but they are not getting employed. Because if they get the employment, they will certainly retain themselves in their core disciplines. They are running for computer and IT sector because they know that after graduating they will soon get a good job. So my question is that if the core sector is rising very fast, the students are also being trained at the institutions very well, like the computer and IT students. Where is the gap that they are not, getting the job or they are not opting for that?
Yeah, I appreciate.
What is distracting them?
I think this needs more deliberation, and I think maybe we'll take this question a little offline due to the paucity of time. I think I will just answer one line. The perception and branding of the core disciplines is what is lacking today. Remaining, maybe we can discuss over lunch. Any other questions? From the back? Is there any student here in the audience? Okay. Oh, there are a few students. Any question from the student? One last question. Can somebody pass on the mics, please? Please introduce yourself and let the question be very short and crisp.
Good afternoon, sir. My name is Amit Kumar and I am a research scholar. Basically working on decarbonizing the hard-to-abate industrial sector, basically in aviation and shipping industry. So, sir, मेरा basically question ये है कि जब हम इंडस्ट्री के साथ कोलैबोरेशन की बात करते हैं, तो सर अगर मैं किसी इंडस्ट्री को अप्रोच करता हूँ या उसके किसी इंजीनियर्स को अप्रोच करता हूँ इन द कॉन्टेक्स्ट ऑफ इंडिया, तो सर मुझे प्रॉब्लम्स होती है उनके साथ कोलैबोरेट करने में. बट रिगार्डिंग ऑल ओवर रेस्ट ऑफ द वर्ल्ड, I have some good collaboration from Australia and USA. So sir, मुझे collaborate करने में वहाँ ज़्यादा easy होती है, but यहाँ अगर मैं इंडिया में approach करता हूँ, तो सर मुझे थोड़ी problems होती है.
तो आपका question क्या है?
So sir, question मेरा ये है कि ये gap जो है कि suppose मैं किसी मतलब reputed institute से नहीं हूँ, तो the main thing is that अगर आप reputed institute से नहीं हो तो आपको यहाँ industry collaboration में कुछ problems आती हैं.
Okay, anybody from my right?
It is not a question of reputation. In the real industry, when we say this company is good, basically we say the people are good. In institution also, if we say institution is good, means students are good. Initially, yes, constants are there, but normally industry don't see the name of institute. I will tell you the other way around. If a new trainee from IIT comes to our company, we will not take him. You know why? Because we do not expect them to work, and we know for sure that the moment he will get better job, he will leave. So we will like take the person from medical college only. Point is, like, okay, you are working on carbon reducing for aircraft. Ships and aircraft.
Basically, I am working on the direct air capture technology and like e-fuel production technology.
Anyway, I'm not going that subject. But yes, you have to keep meeting the industry members and you get the opportunity.
I have one comment. You need to be very visible in LinkedIn. Very, very important. Many companies, they see people who post their passion, everything is tracked through LinkedIn postings and his likes, his profile, how he is connected. We are watching you. Very, very important.
Thank you.
Just to add on relevant projects, right? Like, for example, it's easy to reach out there. It's because you're going to a very targeted person. Given the size of population, number of people in the workforce, you need to be very specific whom you are approaching and you to forget that, hey, I am doing the work, it's relevant to me. With what reason I'm approaching, is it relevant to the person I'm approaching? That's very good.
Yeah, basically, I can give you an example. As I am working on e-fuel production, and there are few companies which are also working on the e-fuel production, like e-methanol and etc. So I approached to one of the company, that is M&S. I approached to this R&D team.
How did you approach?
Through LinkedIn. I represent my recent publication on the e-fuel production also, but unfortunately they did not respond me in any way. So I have approached so many companies also, but in India I did not respond in that way also.
Firstly, M&S does not work in ethanol. Okay, so you have approached the wrong company.
No. One of the R&D unit is also working on that topic also. That's why I approached.
Sure, but there are bigger companies which are working in ethanol, and where you will be able to get some guidance. Everyone is busy, everyone is tied up everywhere, but this initiative, आपने जैसे कहा, ये ज़्यादा बाहर की कंपनीज के अंदर इसको encourage किया जाता है. इंडियन कंपनीज में, बहुत सारी कंपनीज में नहीं किया जाता है. तो इसमें दो राय नहीं है, लेकिन अगर आपका प्रोजेक्ट रेलेवेंट होएगा कंपनी के अंदर, तो कंपनी आपके पीछे भागेगी, ना कि आपको भागेगी. इम्पॉर्टेंट थिंग इज, जैसे आपने बोला कि उस कंपनी के लिए उस रिसर्च का क्या रेलेवेंस है, ये आपको थोड़ा सा एक प्रील्यूड के अंदर लिखना पड़ेगा. अगर वो आप प्रील्यूड के अंदर लिखोगे तो चांसेस हैं कि आपको इनवाइट भी करेगी, आपसे बात भी करेगी और आपसे रिसर्च भी करेगी. लेकिन अगर राइट कंपनी और राइट पर्सन में नहीं करोगे तो वो एक डस्टबिन में चला जाता है. राइट, तो मेरे ख्याल से आपको थोड़ा सा लिखने से पहले, क्योंकि हजारों मेल हो जाती है, राइट, आपको थोड़ा सा रिसर्च करना पड़ेगा कि कौन सी कंपनी सिमिलर एरिया के अंदर काम कर रही है या करना चाहती है. तो आपको जरूर वो मिलेगा, चाहे वो इंडियन हो, चाहे बाहर की हो, चाहे छोटे इंस्टीट्यूट से हो या बड़े इंस्टीट्यूट से हो, रेप्यूटेड से हो या नॉन रेप्यूटेड से हो, उससे फर्क नहीं पड़ेगा. क्योंकि अल्टीमेटली आदमी को देखा जाता है और वर्क को देखा जाता है, ना कि इंस्टीट्यूट सिर्फ को देखा जाता है. इंस्टीट्यूट से भी फर्क पड़ता है, लेकिन जो आप वर्क कर रहे हैं उससे बहुत ज़्यादा रेलेवेंस आती है. सर, मैं आपको थोड़ा सा एक आंसर एक्सटेंड करना चाहूँगा. आज भी हिंदुस्तान में जो मैकेनिकल इंजीनियर है या ऑटोमेशन इंजीनियर है, विद इन मैकेनिकल इंजीनियरिंग अगर हम सिर्फ मैकेनिकल इंजीनियरिंग पढ़ा रहे हैं तो जॉब के प्रॉस्पेक्ट्स उसके बहुत कम हैं. और वही स्टूडेंट आईटी भी जॉब लेता है, आईटी का भी इंटरव्यू देता है, और आईटी वाले डिस्टिंग्विश नहीं करते हैं कि आप कंप्यूटर साइंस से हो या मैकेनिकल इंजीनियर से हो. वो अपना इंडिविजुअल टेस्ट लेते हैं और उस इंडिविजुअल टेस्ट के बेसिस पे आईटी के अंदर भी एम्प्लॉय कर लेते हैं. राइट, लेकिन ऑन द अदर हैंड, जैसे कि AKG कॉलेज, आई एम नॉट क्रिटिसाइजिंग योर कॉलेज प्लीज, ओके, AKG कॉलेज, उन्होंने रोबोटिक ऑटोमेशन का एक कोर्स किया. वो सिर्फ 6 महीने का कोर्स करते हैं. जिस दिन वो कोर्स खत्म होता है उससे पहले उनके 20 के 20 स्टूडेंट एम्प्लॉय हो जाते हैं. इसी तरह से जो आज के दिन में AI के ऊपर जॉब, IIoT के ऊपर काम कर रहे हैं और रिलेटेड टू मैन्युफैक्चरिंग, तो वही मैकेनिकल इंजीनियरिंग में IIoT अगर how IIoT can facilitate the manufacturing, अगर वो कोर्स के अंदर एक इनकॉर्पोरेशन होएगा तो उसके आज के दिन में स्टूडेंट नहीं मिल रहे। जैसे कि आपको मैं एक छोटा सा एग्जांपल देता हूँ, टाइम परमिट्स दिखाऊंगा। Kirloskar Foundry came to us. Kirloskar Foundry had lot of scrap which comes out of the, which is taken in as a part of the foundry this thing, make manufacturing. अब उसका scrap की quality determines the quality of the output and the temperature and other things. If you have the IIoT people trained who can program PLC, okay, I will close this. If you link that, you will find the people employed.
Thank you. Just to answer a specific question of yours on that. There is a counter of ASME over there. Just give your details, write your name, and ASME will connect you with a group of gas turbine specialists who are researchers, who are from the industry, who will address your issue.
Thanks. I think we'd like to close the panel discussion. So we'll just do a concluding 60 seconds, strictly 60 seconds by each panelist. Let me start on my left. And if you would like to sum up this discussion.
Sure. So I think, as we rightly said, I think Mr. Swarup also highlighted, I think cross-collaboration, knowing skills, not just restricting yourself to the conventional that, hey, I'll just do mechanical engineering. The adaptability to learn more, the adaptability to understand what's there and what's there that the industry is demanding, and being open to learning, being a constant learner, that's critical for your growth. Right?
Bottom line, passion, commitment, and the IT-fied skills. You just compare the resume coming from an IT graduate and an Ramaji, you can make yourself very clearly, and that's the demand. So you need to improve the resume to that level so that you get high visibility.
Try to write a resume very simple and straightforward. As a technical people, we should always try to publish few papers in Indian or international journals. The moment those papers are published, your demand will increase in any industry.
I think I've already touched on most of the topics. Thank you.
Okay, just my 60-second takeaway is I think raising the branding and perception of some of these core disciplines. That's one. The second is I think we need a very tighter industry-academia collaboration. And I think, Ramesha mentioned about this, how technology can really be embedded into the curriculum, which can change not only the skill set, but also the mindset. So I think it was a very, very good panel discussion. I would like to thank all my co-panelists, Mr. Sarup Chand, Sanjay Prakash, Ramesha and Puneet. I think personally I learned a lot from this panel discussion. Thank you audience for patiently listening to all the panelists. And last but not the least, I would like to thank once again the host institute AKtU and the organizer of this engineering education seminar by ASME for giving us an opportunity to conduct this panel discussion. Thank you. Cheers.
Before we leave the stage, I would request the Pankaj to give the certificates to the various panelists, starting with Mr. Sanjay Prakash. Rameshna. Lunch is just a little while away, please. Some energy in the clapping. Okay, that's fine. Thank you. So recently we've already given you the certificates. So please wish you all at this point. And can I have sponsors? Thank you. Can we have a...
Sir, Pandit.
Please. Never mind. Thank you to all the panelists and all the speakers for the day.
Okay, we come to the last session, which will be delivered by my colleague, Ms. Avni Malhotra. She is the Deputy Director for Programs and Philanthropy at ASME India. She is soon going to take over the newly formed ASME Foundation in India, which will eventually drive the engineering education portfolio. So it is she and her team which has done all the groundwork in terms of putting this program together. I was only the front face. With due compliments to her on a very well conducted seminar, I would like to invite her to deliver information on education that inspires sustainability in engineering, or to incorporate sustainability in engineering, which is actually the newest ask of the global, education world.
Thank you, Madhukar. We've been listening to everybody since the morning. So my one question to all of you, Hindi या अंग्रेजी? हिंदी में चलेगा अंग्रेजी में? बताइए। दोनों Okay. तो to begin with, ASME के बारे में और हम इस एरिया में क्यों काम कर रहे हैं, क्या काम कर रहे हैं और क्यों काम कर रहे हैं, I will focus on that. So, ASME Foundation essentially focuses on empowering the next generation of engineers. ASME Foundation का base जो है वो ASME है. ASME is the American Society for Mechanical Engineers. ये 140 साल पुरानी संस्था है जिसमें इंजीनियर्स एकत्रित हुए और उन्होंने एक ग्रुप बनाया जिससे वो इंजीनियरिंग को बेहतर कर सकें, स्पेशली मैकेनिकल इंजीनियरिंग को. तो ये संस्था करती क्या है ASME? ASME essentially works on standards and codes. So they set standards. Their most famous standard is the boiler vessel code that they made 140 years ago. So looking at that, they set standards for how industry can function better, how industry can be more efficient, and how we can produce better and safer working conditions for various kinds of work, or especially engineering that we do. In addition to that, we also do learning and development, क्योंकि standards बनाने के लिए आपको लोगों को train करना पड़ेगा, तो learning and development comes very naturally as a byproduct. You are also setting new standards. So you organize volunteer groups who come together to set these standards. So this is what essentially ASME does. What does it do in the area of engineering education is what I am going to essentially share with you. So it has three main streams: education that inspires, careers that matter, and ideas that innovate. Education that inspires essentially works with students and faculty, and it looks at various engineering initiatives that make engineering very innovative, very competitive, and very interesting. It has a plethora of competitions that happen, as well as scholarships and fellowships that are given out. Careers that matter. So we are at an age where we are facing climate change, where there are questions about sustainability. So careers that matter essentially focuses on how do you make engineers relevant towards sustainability and the world that is going to come tomorrow. How do engineers work towards solving the problems of tomorrow? Ideas that innovate essentially is an engine that focuses on engineers for change, looks at sustainability and innovation, and looks at startups and how do we support people who are innovating in this field. Education that inspires essentially works with students. So how do we work with students? So we have linked over about 21,000 students in various competitions, and the two competitions that two engineering festivals that we organize are EFX and EFES. EFES is a virtual platform, but EFX is our platforms in which competitions are arranged and organized between students, and any ASME member, student community member, that is a student section, which is over 15 students, come together to form a student section, they can organize in EFX. So this is a very popular program. In this year, we have organized 3, and we are hoping to organize 4 to 5 more before September. Looking at engineering education, we have lots of scholarships that we give out. If you go to the ASME page, बहुत सारी scholarships मिलेंगी, जिसके लिए कई जगह हम eligible होते हैं और कई जगह नहीं. But these scholarships are available to students who are ASME members, and some of them are very relevant, very encouraging scholarships. Number of students in India have won these scholarships. Over 21 students last year got these scholarships. Overall, over $500,000 have been distributed in these scholarships to over 100 plus students. Careers that matter. Looking at, question we had from Amit here, looking at what do we do that will make a difference in this world. So these are 2 people who have been associated with ASME. They have been ASME fellows. Do look at their LinkedIn profile, and you will see that they have done some very innovative work. Nishant has runs an organization called Life and Live, and he is responsible for producing a prosthetic hand which has helped many people, and he has a factory in Ghaziabad. Himanshu Pandey is looking at how discrimination is handled on the internet, and his work is also commendable. And you will, if you go onto their LinkedIn pages and their Instagram, you will find it very inspiring, the work that these 2 boys have done. Ideas that innovate. So we are also looking at how do we deal with the changes that are taking place on this planet, how do we make our work relevant, sustainable, and answering the questions that are being raised today, especially about climate change. So we have a parallel company called Engineers for Change, and this work is being done by this company. It has a very strong internet presence, and fellows of over 65 fellows every year do research with us for over 5 months, and their work is published on this site called Engineers for Change. Some work is very relevant, it could inform your own research research, your own questions that you have. So do look at that as well. We try to support life-changing solutions that some of our fellows have have made with us, and one of the platforms that help them do this is called Idea Lab, where we look at an idea at its generation stage, at its design stage, and we support students at that level. And later on, when they innovate and get some support and some funding, we work with them for them to showcase their innovations, and that is called iShow. So both these programs are ongoing. iShow is something we just concluded last week, and we had 7 competitors, and 3 of them won an award of $10,000 each. In our work, we have to be very responsible. So all our data is collected as per various indicators and shared on an internet site, and to show that we are socially responsible, so that the return on investment can be calculated in both technical and social terms. So looking at our impact and what we are doing is also equally important. We are working all the time for equity, so we have some projects in the offing and on the bench which are looking at how we can look at diversity, equity and inclusion in engineering. Okay, MEED. Why are we here for MEED? So MEED is Mechanical Engineering Leadership Summit. It is organized since 1989 for many years in the US, and we brought it to India in 2022. In 22, because of COVID, we had to have a virtual conference similar to the one we are having here. And in 23, we met up in a face-to-face conference in Bangalore. Then we realized that we need more involvement, more engagement, and therefore we are going now this year from region to region, and in that region to region also, from state to state, because we are kind of moving from one university to another. We are looking essentially at the future of manufacturing. We are also looking at the social impact focused on innovation and entrepreneurship, which was the topic that we covered in 23. And we're trying to bridge the gap, which is something you have just witnessed today, as to what is it that is required by industry, by the world today, and what is it that we are learning, how do we bridge the gap, and how do we make our engineering courses more relevant for the world of tomorrow. This is the vision of MEED. It is essentially to look at how do we build an engineer, what is it that is required, what is it that needs to be done. So in the previous conferences, what has emerged is one, which in some ways in the previous sections, the panel discussion was summarized by Deepanka, is essentially that we want engineers to get an overall experience, and to do that we need professors of practice to come to the educational institutions and share with them. We need industry to support research taking place within the educational institutions, and we need to discuss this, and we need to take this discussion to stakeholders like AICTE, NBA, and ask them to look at what needs to be done in the curriculum in order to make the course more relevant. Guiding us, we have a stellar steering committee. If you look at the names here, they're the who's who of the mechanical engineering today, and we come together before and after each such conference and seminar and discuss the findings, and they kind of guide us. So in the beginning of the year, we were doing only one seminar in Anna University, and when we finished that, some of them came back to us and said, what about North India? Why don't you do it with AKtU? And that is how we landed up here. We are now taking it to Pune University, and only yesterday we had a discussion with someone who is trying to help us organize a similar seminar somewhere in East India. So we are trying to do this in all 4 corners of the country, so that we have a plethora of opinions and participants who can inform us better. This I've just shared with you. We hope to have a roundtable with everybody's findings finally in the calendar year 2024. That's it from me. I hope this was helpful. Before I finish, I've been asked to tell you that there is a membership booth at the back. Please have a look at it, and since you are going to now be in our database, we are going to get in touch with you. We would request every college that has participated to set up a student section, have the benefit of being a member, look at various festivals we organize, various scholarships your students can get, and also as faculty members, what are the benefits that you can get by being a professional member of ASME. Sorry? And yeah, the various training programs and various, well, if you go onto our learning and development page, you will see various opportunities that you get to participate in training. And you will also get 3 training courses free, so you can look at that also as an opportunity in the future. Thank you so much for being here with us today. And now I'd like to invite Neelam Satdeva to give us the final vote of thanks. Thank you for coming.
Good afternoon, everyone. This is a new sort of activity which we are doing at AKtU under the umbrella of Training and Placement Center. So it's a great opportunity for all the persons who came here from their colleges. I think you all have gained some or the other interesting thing from your college point of view, and you can make use of that and spread that in your college. Because I'm here for vote of thanks, so starting from our Vice Chancellor who initiated this seminar to head here, so big thanks to our Vice Chancellor sir for making this event happen under AKtU, and so that our college directors and training and placement heads and various HODs, especially of mechanical department, get benefit of this seminar. In the keynote address of Professor Rajiv Kumar, Member Secretary of AICTE, as we all know, AICTE is always had a very good handshaking with AICTE, with AKtU colleges or with AKtU, and we try to inculcate all the ideas and all the possibilities which AICTE floats. For example, implementation of NEP. For example, earlier it was you can say elective courses, and now those value education. I think AKtU is the first university which had so many value education courses in their curriculum, starting from first year to final year. Either it is in the form of some credit or it is in the form of 0 credit. We are providing these value education to our students. So this AICTE Member Secretary also talk of the bridge the gap of industry academia personal, and this is one such activity where we try to bridge the industry and academia. It's my personal version that once we join these academic institutions, there is very less formal linkage between industry and institute. So it is a good opportunity, and we were talking with other industry persons also to have such FTPs for our faculties also, so that the need of industry is percolated in such a way so that we can add value education to our, or value addition to our faculties, and so that they can pass it to the students also. Coming to Professor Madhukar Sharma ji, President ASME, and Avni Malhotra, who were the key persons to hold this seminar. So I am very much thankful to Madhukar ji and Avni. Because of your efforts, we had such a good panel, and we come to know many new things which is going to benefit us. The very important thing or very important conclusion which we come to know from this seminar is the multidisciplinary need is important. So we are floating our electives in such a way so that we get the multidisciplinary concept of various educations, and we are going for minor degrees also. This AKtU is planning and implementing, which will again help in this multidisciplinary need of the society. Then my thanks to all the panel members, and I am very thankful that when the people are talking of AI, when the people are talking of IoT, we are having the experts from very core engineering, from core industries, which will give the hope among the students that yes, core industries are working very good, and they are open to train our students, to develop the skill of our students, so that they can get good opportunities in the core area also, apart from the computer science related areas. So with these words, because it's already 1:30, it's a time of lunch, so I thank all my college fellows who are here and making this event a big success. Thank you so much, and we can come and join. Good lunches waiting for you all. Thank you so much.
Okay, thanks everybody. Please join for lunch.
We have to move to first floor for the lunch.